Well, a very, very good morning, good afternoon, good evening. My name is Ashley Owen, otherwise known as Ash, and I am Head of Product Marketing here at OpsMx, and I'm delighted to welcome you to today's webinar. Today, we are presenting SaaS Spinnaker, Secrets of Successful Delivery. I'm joined by my wonderful colleague, Srini. Good morning, good afternoon, Srini. Srini has 25 plus years, about the same as me, in fact, of experience in software architecture, design, hands-on development, testing, implementation, and maintenance, both in agile and waterfall methodologies. And he has done so across both the USA, Germany, and India. And currently he heads a very important role, customer success here at OpsMx. Welcome, Srini. A little housekeeping before we get started, and then I'll cover the first slide, and I think I then run a quick poll. If you have any questions during the presentation, I encourage you to type them into the chat box or the Q&A panel. We'll find them one or the other, and we'll be happy to address questions at the end. Next slide, please, Srini. Excellent. So it's interesting. Quick introduction to OpsMx. I'm sure you're all very familiar with it. I'll just give you my perspective. We're in an area where we're modernizing business applications, and it's driving the adoption of cloud-native architecture and a need to modernize continuous delivery and infrastructure automation. OpsMx Intelligent Software Delivery Platform is a modern continuous delivery solution based on Spinnaker, our beloved Spinnaker, designed to increase the speed of delivery safely and securely without human intervention. Of course, we use OpsMx Enterprise for Spinnaker to orchestrate the end-to-end process workflow for code check-in to safe multi-cloud deployments, increasing the productivity and efficiency of your DevOps teams. And with Autopilot and our data and intelligence layer, we provide insightful, data-driven risk verification, policy enforcement, and informed approvals to speed delivery and quality of risk-free and compliant software into production. And of course, we provide all of this in SaaS with OpsMX Intelligent Cloud. Next slide, please, Srini. So I'm going to run a quick poll. I'd be very appreciative if you could put your answers in now. Are you currently doing continuous delivery? If yes, with what percentage of your current production applications? And whilst you're doing that, I'll just reiterate that housekeeping. If you do have any questions during the presentation, I do put them in the chat box or the Q&A panel, and we'll get round to answering them. Give the poll just a few more seconds. I'll minimize it for now. Next slide, please, Srini. Over to you, sir.
All right. Thanks, Ash. I appreciate that. Thanks to all of you for joining us today. What we are talking about here is continuous delivery. In an ideal world, the moment a developer commits the code, it's in production. That would be the end goal or an idealistic goal we all are working towards. However, that is unrealistic because we want to make sure that once the code is committed, we are absolutely sure that when it goes into production, we are not breaking something. And that's roughly the theme of continuous delivery and the tools we are talking tonight. So what happens is that in a regular process, to make sure that things don't break, we have various tools, static analysis, integration testing. There may be other automated testing, and then somebody has to review the results of these. Tests, and it's good. Additional testing happens, and there are additional checks and balances, making sure that things are working okay. And then finally, it goes to production. Typically, to reduce risk, in more mature organizations, you may have a canary kind of a rollout where the traffic from the end users is sent to a very small percentage of the traffic is routed to the new version, so that if there is any impact, at least it's not like a big blast or something. It's just some users might be impacted, and there is a comparison done. We check out if the canary is okay, and if it is okay, then we go to full production, gradually shifting the traffic from the old version to the newer version. Of course, otherwise we want to roll it back. Now, what happens is that when we want, on one side, the moment code commit happens, we want to go to production. So we want velocity. We want to go as fast as possible. This is almost like driving a car on an autobahn or something, where you want to go as fast as you can. At the same time, you want to make sure that all the rules are being followed. We have all the checks and balances placed. Wherever there's a stop sign, we stop, and so on and so forth. But the faster we go, and the faster we want to go, higher is the risk. Typically, let's take a simple example where our error rate of something going into production is, let's say, 1 in 1,000. 1 in 1,000 sounds pretty good, actually. So if we are deploying, once a day, then might have some issue with production, once in 3 years. But let's say, for example, some of the large companies like Netflix, they make anywhere between 8,000 to 10,000 deployments per day in their worldwide network. Now, once you are deploying at that speed, and that scale, suddenly you realize that the chances of having an error is almost every day or every few days. And we want to make sure that the entire continuous delivery at that speed still works. And now we are looking at reducing your error rate to 1 in 1,000,000 or 1 in 10 million. And that's really what we are talking about here. So what is actually preventing velocity at scale? Let's take a quick look. What are things that are slowing us down? First and foremost is scripts and manual processes. And these things take time. They're potentially error prone, and manual process require humans to be available, and they slow things down. Some of the things also comes from the complexity that's coming up because of cloud infrastructure. In the pre-cloud days, everything was on-prem or in one data center, and was far more homogeneous. Now, in a multi-cloud situation, like we have examples where people are switching from one cloud to another, complexity increases, things take more time, people need to do more manual steps, more checking, more things break, scripts fail, and people have to go look at it and fix it, and so on. So the complexity of multi-cloud deployments and strategies, even canary deployment, it does add an extra layer of manual overhead and a time-consuming process. And in general, when you're talking about complex pipelines or long-running pipelines, you have staging, we have dev, we have production. So probably a simplistic scenario. Very frequently, we have scenarios where in a microservices architecture, there are multiple environments, and all these environments need to be looked at and dealt with, and that adds to the additional complication. So what are the factors that increase risk? Let's take a quick look. So any kind of a manual process is almost certainly a cause of risk. Whenever we touch something, there is risk. And any human activity results in potential human error. Inconsistent security reviews. So when we talk about risk is not necessarily a functional risk. Maybe things are working fine. However, a deployment could open up a port or could configure a load balancer or something that might put the entire company's infrastructure at risk. So security review and making sure that whatever is going to production is secure. It's not going to cause any additional, opening of the network to the external traffic and so on. This requires typically a review, particularly, let's say if you have a Terraform stage or something in a script, somebody has to actually go inside the script to see what it's doing. And let's just say that our regular guy or girl who is doing the security review happens to be on leave, and somebody else who's a backup does this, and that results in a complication. Complexity of policy enforcement. Now, in any company, typically there will be policies associated with the application deployment, maybe applying specific tags, as I said, ensuring that if you are creating a load balancer, that's an internal load balancer, not an external load balancer, opening up of ports, only certain ports may be allowed, and so on and so forth. And most common scenarios of policy enforcement might mean saying that Docker images only come from the company's internal repo as against a public repo, or Docker images should be scanned before deployment, and they shouldn't have any security, critical or serious security issues. So these are examples of policy, and these are typically written, and but enforcing these policies becomes a challenge. So let's quickly take a look at Spinnaker that offers solutions for a lot of these issues, and then we'll look at how we overcome these. So for most of you probably might already be aware of Spinnaker, and I just take 1 minute, maybe 30 seconds to explain what it is. It's a microservices-based application that was developed in Netflix about 4 or 5 years ago, and then it was made open source, and it's been battle tested for deployment across hundreds of organizations. Some of the top tier organizations are using this, and we want to make sure that we leverage the functionality that Spinnaker offers. So just 1 minute, someone is typing continuously, causing me to get distracted. All right. So one of the biggest factors that Spinnaker is scalability. And we are talking of thousands of pipelines. We are talking about deployment across 100, 200 different clusters. We are also talking about pipelines that are fairly complex, pipelines that include like an if then else logic, including automated rollbacks. It natively supports canary, blue-green kind of pipelines. So Spinnaker basically comes with very, very rich functionality that is battle tested, scales, and deploys just about everywhere. So on one side, Spinnaker is an excellent solution, fairly easy to install and configure. However, as we mature and want to use Spinnaker at scale, use Spinnaker in a production environment, then suddenly we realize that the skills needed and the learning curve gets rather steep. And that is true, I think, with any microservices-based architecture. Spinnaker has about 10 different microservices using different functionalities. So understanding them, scaling, setting, limits for memory, CPU for each one of them, and replicas counts for some of them. All these requires specialized knowledge and experience. Similarly, onboarding new users and applications, typically training all the users to use Spinnaker can take some time and effort. In a production environment, we want to monitor Spinnaker for 24/7 support, make sure that if something is not working, we need to increase the replicas, or we need to increase the memory for some of these parts. We want to be able to monitor and respond to them quickly. And of course, ensuring security of the entire platform itself, that's a Spinnaker and the tools platform, in addition to the security of the deployments. This is, again, it gets pretty tricky at various levels. As I said, this is true for any application, and typically for deployments, the developers would know, the system would know, but ensuring that Spinnaker itself is secure requires, again, additional work. And the same thing goes with upgrades and integration. Spinnaker integrates with just about everything there is in the market, be it Jenkins, CI, and so on, or GitHub, GitLab, and so on. So this part requires specialized skills and involves some time and learning on part of the organization. At OpsMx, we do this for a living. We do and live migrating applications from, let's say, GitLab to Spinnaker, migrating applications from Jenkins to Spinnaker, or using Jenkins there, but deploying using Spinnaker, and so on and so forth. So for us, we are the experts in this, and for us, it doesn't take any time to execute most of these. And the SaaS platform essentially gets us going in minutes rather than days. And the entire operational overhead associated with the complex tools such as Spinnaker, which is also, of course, extraordinarily powerful, gives us the ability to be able to use the benefits or gain the benefits of the software without having to deal with the operational overhead. So OpsMx Intelligent Cloud is essentially an enterprise-grade platform that we can set up in a matter of an hour or so, which includes self-service application onboarding. We have a library of sample pipelines and templates, which makes the learning curve very short, and be able to create application pipelines very, very easily. Spinnaker and OpsMx provides RBAC, role-based access control, so we can help integrate OES or OIC with your SAML, OAuth, or LDAP, AD, whatever you have, and use the groups in there as the basis for providing access control. Deploy anywhere. I'll talk more about this. We have an agent that allows you to deploy in your private environment, in your cloud, private cloud, without ever having to share your credentials. That is, the secrets or credentials associated with the clusters or Jenkins databases, passwords. None of them ever leave your environment. So this is what I'll talk about. It integrates with all the tools you need, and we provide a multi-region high availability and a disaster recovery to make sure that it's available all the time. And should an entire region, as it happened recently, there was an outage on AWS Eastern region, and should that happen, you would have almost no impact. Policy enforcement of pipelines this is one of those strongest features that we provide that allows you to programmatically enforce organizational policy. So essentially, all the data, the variables, or whatever values we have in a pipeline are available to us to enforce a policy. So any arbitrary policy can be executed as long as the variables or the data that is needed to enforce the policy is available in the pipeline. That's all that's needed, because all that data is there, and we use OPA, Open Policy Agent, which has its own very simple language called Rego, or REGO. And using that, we can write policies that get enforced both at pipeline creation time, we call them static policy, and pipeline execution time, which is called runtime policy. So both of them can be enforced to make sure that the organizational policies are followed, or else a pipeline fails. So essentially, there is no way the policies can be broken or subverted and create a risk by putting something on production, let's say from a public Docker repo. Intelligent risk assessment, we have a AI ML-based algorithm that compares two sets of logs and metrics and finds out the logical distance between these two. It gets a bit involved to explain how it does it, but let us say that we have a system that's already running, and typically all applications generate some logs and metrics. And when we are putting a newer version, we could run it for a few minutes and then compare the logs and metrics. And for example, if the newer version is consuming, let's say, 50% more CPU, we may not see it. And when we are, the load is not very high, we may not even notice that there is an issue. But once it goes into production, then suddenly we see that, the performance is degraded. So from metric standpoint, whatever metrics are available using Prometheus or Datadog, what have you, AppDynamics, we can use those. And similarly for logs, we have, Elastic and Splunk and so on and so forth. Informed decisions, as I mentioned multiple places, when we have manual reviews, manual decisions, typically a senior person might ask for checking the report of a sonar cube scan, maybe a aqua scan, image scan results, test results, and so on and so forth, before the person approves something to go to production. And what we do here is that we pull data from multiple data sources and make them available all in one place. And this is a stage in the pipeline, and the approval is possible straight from the screen. So in the moment the person approves it, it's also possible to take some notes over there. So it becomes, there is a log as to why or how a person has approved, what the person has seen before approving. And the pipeline goes forward and deploys it to production or whatever the next stage might be. So this also results in auditability, traceability, what has happened, who did what, when, how, when was it last deployed. So observability and traceability of deployments also becomes a critical element of this, something that is required in many organizations, particularly financial organizations, where auditability is almost a government mandate. And insights essentially takes data from various sources, mainly from Spinnaker, but uses data from other sources, and provides graphical representation of the aggregate data. So how many pipelines failed over the last week, for example, might be a question. Which pipelines keep failing most frequently? And using that, it's possible to optimize the overall DevOps processes in the aggregate. So let's take a quick look at what I talked about, the agent. And in the agent, OpsMx Cloud is somewhere. Even though I'm talking about OpsMx Cloud being in cloud, please do understand that we do have the same solution on-prem. In fact, some of our customers are using that, and we provide managed support for absolutely the same software, except that the installation is in the customer's environment as against ours. And the idea here is that the software is running in cloud. There is an agent which sits behind the firewall. So what you see on the screen on the right side is essentially your environment, the customer environment, whereas what's on the left side is the internet, the public cloud. So the cloud, the software talks to the agent through the firewall. There is absolutely no need to open any ports. We do need an outbound traffic from the agent going to the cloud, and it uses gRPC over TLS. It's a completely secure communication tunnel that's established, essentially like VPN. And the traffic gets routed from the Spinnaker and OES software to the agent. And the agent essentially talks to all your internal tools which are sitting behind the firewall, and it will go ahead and do the thing, like deploy within your development environment, deploy within your access data within your environment, and so on and so forth. Even if we are using cloud, let's say we are using Datadog, and that's on the cloud. Maybe we have a VPC, we have security around it. So in the example shown on the screen, let's say we have AWS and we have a private VPC that connects to your company's infrastructure. Even then, it's possible for the agent to access AWS through your systems. So whether it is Kubernetes or AWS or Azure, all of them provide private clouds, and the agent does exactly that. So your private cloud is still not accessible from the internet, but the agent takes instructions from the cloud software and does the job. So this is how the agent works. And we'll take a quick look. So let me quickly show you what the software looks like. This is a demo, is probably a misnomer here, just an overview of what we have. One is the application dashboard, where you can see that there is an aggregate display of functionality, which talks about deployments, approvals, policy violations, and so on, and what services you have in each of these applications. This is what I said, insights, where you can see the graph of how many deployments happened over time, or what are the most frequently failed pipelines, the most successful ones, the most active pipelines, and so on. This is a slightly older version on our demo server. The newer version allows a lot more functionality here, which tells you how many different gates were used, how many pipelines were running simultaneously at any given point of time, and so on and so forth. So this is just an example of even manual judgments. How long was it sitting before somebody acted on it, for example. So this is a very, very useful tool for aggregate optimization. So this is a verification stage, which I talked about. Should have probably clicked on this. So what I talked about, the AI ML part of the verification, this is fairly involved. We'll probably have a session on this separately, but just to let you know that you can see that it compares metrics of two different types, the baseline and the new release, and makes an assessment whether, as per the metrics that have been selected, whether the application after the change is okay or not. And we can kind of set thresholds, and there are scores. Based on this score, it's possible for the pipelines to automatically go forward or fail, or just sit there waiting for a manual intervention to take position. So this is what is the verification we're talking about. The auditability, as I said, aggregate data processing. It's very, very useful when we want to see and dig up pipeline or information across different applications in Spinnaker. And you can see how many of them fail. It's even possible to filter certain pipelines by which ones failed for various reasons, how frequently, and so on and so forth. There's a pipeline execution data, there's pipeline data itself, so I can get an idea of how many pipelines are there. So I quickly come to the agent I talked about. So this is a couple of agents that are running here, and you can see that this is running in a different cluster, and it shows you what all services this particular agent provides. So essentially, it is possible to configure the agent to your clusters, your data sources, your Jenkins, or whatever. And those details actually never come here. Actually, they never leave your system. The secrets stay where they should be. They do not go onto the SaaS instance. And you can see that this is a URL which is completely incorrect. It is the Jenkins URL has a Jenkins in it, but it's essentially getting routed to the controller, and the controller routes it to the real Jenkins. So that information, even the Jenkins URL, will never show up here on the system. And you can have multiple agents, which also helps separate, the team A, team B, team C kind of scenario, where there are three teams, and they don't actually need to be able to see what the other team is doing. So the complete separation in terms of data sources, in terms of clusters, in terms of applications is possible. And you can have essentially multiple tenants, so to speak. So we have customers where they have multiple teams, and being a financial organization, they don't want one team to be able to see even the application names of the other team, and that becomes possible and is further reinforced by the agent. So let me quickly go back to the presentation. So here is a summary of what we have seen. We can get started with Spinnaker and OES in just about an hour. It's a UI-based account setup. There's a lot more we can talk about, but I don't want to go into the details at this point. We can set up policies, approvals, and verification gates, and ensure that there is complete visibility of the CI/CD pipelines. From a business value perspective, most of it, our customers are fairly competent. You can do it yourself, except that there's a huge learning curve and it takes a lot longer in a make versus buy situation. It's shorter time to market, easier and faster to get the deployment stage. We have complete, production grade installation with all the secrets stored in Vault, and it's close to impossible to get access to any of the secrets that are there in this instance. Of course, it's completely compliant with security and standards. Over to you, Ash.
Thank you very much, Srini, for that very informative presentation and a little bit of a demo walkthrough. Really do appreciate it, and I hope people found it valuable. Let's quickly run on to our second poll, and I'll just bring it up now. Click on number 2. There we go. For those that can, is your organization currently evaluating or using Spinnaker? There you go. Boom. And I expect many of you are, or some not. Excellent. Awesome. So while we do that, I want to make sure that if you've got the opportunity and you haven't done so, please enter any questions you have in the chat or Q&A window. I'm just going to look into that. Before we go into Q&A, I want to ask Srini, is there anything else you'd like to sort of share with the attendees at this point, or are you effectively want to follow up after the Q&A?
Yeah, I guess we can move to the QA, but I'd like to point out that if anybody's interested, we can go into more details, particularly with the verification and the approval stages. I just had to skim through them due to time constraints, but the depth of the machine learning algorithm and the kind of value it brings to the table for use cases, including quickly finding defects, relating defects to log entries and so on. So a lot of use cases over there. And if someone is interested, we are happy to walk them through at a later point.
Yeah, I mean, I couldn't agree more. In fact, I was talking to a customer recently who their QA organization was checking logs and automating that through our analysis. And they actually found on implementation, our intelligence layer actually found some other potential production issues that their testing had missed. Yeah, very encouraging. Okie doke, let's see if we can go to Q&A then. I'm just going to check in the chat window. Is there anything? No, is there anything in the Q&A window? We don't seem to have any questions. All right, well, there's one thing I will say for those that haven't seen it. We did an announcement partnership with Google recently, and OpsMx are going to provide the Google Cloud customers with the intelligent delivery platform and expert support, so some of which you have seen today. Srini, do you want to move it to the next slide? I think there's an in slide there. All right, so there it is. There's an offer that you guys can see. So if there are no questions, I'm sure Srini and I are happy to answer any questions, but I don't see any questions at this point. So I would encourage you to follow up with us. Sometimes it's easier to follow up rather than on a webinar, and we'd be delighted to hear from you. Srini, thank you very much indeed. I think we've covered everything, and I look forward to seeing everybody at our next webinar. Thank you very much. Bye-bye.
Thanks, everyone. Cheers.